After we understand money and monetary system we discussed in chapter 4, now we are stepping into chapter 5 to discuss inflation, the causes, effects, and social costs of inflation. Okay? And we're going to start with a very simple theory. It's called quantity theory of money, which helps us understand how much money we need in our economy. Okay, this theory, as I said, it's very straightforward, and there's only one single equation we need to understand. It's called quantity equation of money. Okay, and this equation builds a connection between the real economy and the monetary economy. All right. And we're going to assume in this theory that money used primarily as a medium of exchange. If you remember back in chapter 4, we introduced 3 functions of money, right? So here we're saying that money has been used primarily just as the medium of exchange, okay? Because of that, then we could say how much money we need depends upon how much we produce. Okay. Now here, 2 things we need to clarify. Number one, when we use the word money here in this chapter, what we mean is the money circulating in our economy. So it's not an indicator of wealth. Okay. Of course, when we talk about wealth, we said the more money we have, the better we are, right? And or the wealthier we are. And but again, that's not what we're talking about here. So when we say how much money we need, that means we want to have what we produce, like the goods and services, to be able to bought and sold on the market. Okay, so the money here is to facilitate the transaction of our output. Okay, that's why we said it depends upon how much we produce. And a very simple example of one product economy can help us understand this. So let's say in our hypothetical economy, okay, and we only produce one thing, oranges. Okay, if we produced $10 oranges, then we basically just need $10 to make sure these oranges we produced can be bought and sold on the market. All right. And so here, let's talk about 2 equations. The first one is these 2 are just 2 variations of the same equation, okay, the quantity equation of money. The first one is focused upon absolute level. The second one will focus upon the percentage change. Okay. Now the level equation says P times Y equals M times V. Here, P stands for overall price level, okay, which is measured by, again, you can pause the video and think about, what macroeconomic indicator we learned before can be used to measure the overall price level. All right, there are at least 2 we already learned, okay? CPI, Consumer Price Index, and GDP deflator. Okay, you probably remember we briefly talked about PPI, okay, price product producers price index. Okay, and so here we believe that the GDP deflator is the most appropriate one because we're going to talk about our output, right, which is Y here in the equation. Y stands for the quantity of output. Again, you can pause the video and think about what indicator we can use to capture Y. In practice, we use the real GDP to measure Y. Okay. Now, real GDP is not really in the quantity of output because we still use the price, right? But remember, we use the base year price, right? So here, price won't affect any change in real GDP. So we can, roughly speaking, take real GDP as a measure of quantity of output, okay? Because in reality, for example, in the U.S. economy, we produce like hundreds of thousands, if not more, goods and services, right? So we cannot, come up with a thorough list of a quantity of each good or service, right? We still have to rely upon the price, okay? All right, so if Y is the real GDP and P is the GDP deflator, you probably already guessed that P times Y should be nominal GDP, okay? Nominal GDP is on the left-hand side of this equation. On the right-hand side, the first variable M stands for money supply, okay? Which could be measured, again, back in chapter 4, we said that we have multiple measures of money, M1, M2, M3, MZM, etc., right? The most commonly used one as a measure of money supply is M2, all right? And the last variable on the right-hand side of the equation, V, stands for velocity of money, okay? Which means the number of times an average dollar bill changes hands, okay? Like within a given period of time, okay? All right, the second equation, or the second variation of the equation, is the change, okay? We focused upon the percentage change, which is built upon the level equation, okay? So here we said the percentage change of P times Y equals the percentage change of M times V, all right? Now, here, mathematically, we believe that if we open the brackets, okay, the percentage change of a product of two variables should be equal to a sum of percentage change of each variable, okay? In other words, we should put the plus sign here in between, okay, for both sides of the equation. So the percentage change in overall price level plus the percentage change in real GDP should be equal to percentage change in money supply plus percentage change in velocity, okay? All right, now here let me go back and briefly talk about the intuition of the level equation, okay? As we said, the left-hand side is a nominal GDP. So if we still use this one product economy as an example, we said that we produce oranges, right? We don't produce anything else. That's the only product. So suppose we produced 10 oranges, and the price of orange is $1 each. Then our nominal GDP would be $1 times 10, so it's $10, right? So that's the left-hand side. That's the nominal value of our output, okay? So that shows our real economy, how much we actually produced in current dollars, right? On the right-hand side, it's a monetary economy. Now, we produce $10 oranges. Does that mean we lead $10 money, okay, to facilitate the transactions of oranges? No, not necessarily. Because remember, if I spend $1 purchasing one orange you produced, then when you receive this $1 bill, you can turn around and spend it again, right? So the same dollar bill can be spent over and over again within 1 year, let's say, right? That's so-called the velocity of money, okay? So for example, if every dollar bill on average is like change hands twice in a year, that means we only need $5 bills, okay, to facilitate the transaction of $10 oranges, okay, because $5 times 2 times per year, okay, these dollar bills change hands. That means we will have $10 on the market for people to spend purchasing oranges, right? Okay. Now, to continue our discussion, especially about this percentage change equation, we're gonna make a strong assumption, which says the constant velocity over time. In other words, the number of times a typical dollar bill changes hands doesn't change over time. It stays constant. Again, this is just, help us simplify our analysis, okay? Later in this chapter, we're going to check out, how true this assumption is on the ground, okay? We're going to check out the velocity measures. Now, because we assume the velocity is constant, so of course, the percentage change in velocity is going to be 0, okay? It's 0 because constant doesn't change at all. And then we plug this back into that percentage change equation. We're going to get percentage change in price plus percentage change in real GDP equals percentage change in money supply. Okay, the percentage change in V disappears because it equals 0. All right. Now here, if you remember back in chapter 8, when we talk about economic growth, we said that at least for the U.S. economy in the past 150 years, the economic growth rate on average is about 3 to 3.5%. Okay. Now, if we believe that the percentage change in y is just that number, okay, it's again close to a constant, then we're gonna get a one-on-one relationship between the percentage change in price and the percentage change in money supply. Okay, and so that's here the relationship among money, price, and the inflation. Okay, and the quantity theory predicts a 1-for-1 relationship between the change in the money growth rate and the change in the inflation rate. So here in the equation, again, the percentage change in price, in overall price level, that is inflation rate. Okay, that's inflation rate. On the right-hand side, that percentage change in money supply, that's the growth rate of money. All right, and again, we reach this conclusion by assuming that the velocity is constant and also the real GDP growth rate is constant. Okay, if neither of these is constant, then of course the theory would be different. Okay, would predict a different relationship. All right, now here we finish our discussion about the quantity theory of money. Okay, again, there's only one equation. It's called quantity equation of money. Okay, we discussed the mathematical derivation and economic intuition. The next video, we're going to check out the empirical evidence, okay, to see if this equation holds in reality. All right.